Alright, so in this video we're going to look at two sort of specific examples of Lewis structures. The first one is resonance structure. How do you draw a structure that has sort of an ambiguous situation as to where multiple bonds go, so the doubles or the triples. The second one is formal charge. How do you use formal charge to help you identify what resonance structure amongst sort of some uneven asymmetrical molecules, which resonance structure is the most important or most likely to be correct. So first one we're going to look at is just this NO2 minus, so resonance structure. If we look at NO2 minus, the first step we're going to follow the same exact things we do for any Lewis structure. So we need to identify the number of valence electrons. That's 5 for the nitrogen, 2 times 6 for the oxygen gives me 12, and there's one more for the negative charge. So at the end of all this we're ending up with 18 electrons. Okay, so I have 18 total electrons for my valence electrons I'm dealing with, and now I'm going to go ahead and just lay out the structure. So first thing I do is put the nitrogen in the middle, follow my rules here, put the other atoms inside of it. I'm going to complete the octets. Okay, and if you look right now, if I were to count, 2, 4, 6, 8, 14, 16, 18, okay. But we have a problem here, which is to say that right now our nitrogen only has 6. We've drawn everything in we can, so for my rules I'm going to take away 2 of those electrons and I'm going to put a double bond. Okay, since this is NO2 minus, we should denote that. Now note that this is ambiguous. Whether we put, it didn't really matter whether we put the double bond on this oxygen or this one. They're identical. Right? So in reality what happens is sort of a 50-50 chance it could happen the other way. So you could very well be looking at this case, the double bond to the oxygen on the right. Okay, and the way you denote this is you simply draw both structures and show that, okay, we've got a resonance structure here between the two of them. Sometimes it's the oxygen on the left, sometimes the oxygen on the right. If you were to actually look at these and the characteristics of these bonds, both of those bonds are going to be somewhere in between a single bond and a double bond, showing that they resonate back and forth between the two. So neither one is fully the double or the single, but rather both sort of exist at once. Okay, so that's how you would do a resonance structure. If you had 3 and a 3 minus, you would go ahead and do that. Now the next case we're going to look at is a case where it's not symmetrical, so it's not between two identical O's, but the actual resonance structure is between two different things, and we have to figure out what they are. Alright, so now let's look at the case where you can have multiple Lewis structures and you're going to need to use formal charge to figure out which is the most important. We're looking at the thiocyanate ion, SCN-, and we want to find the most important structure using the formal charge. So this pretty much right here, the most important structure, is telling us that there's going to be some kind of asymmetry to this. There's going to be a couple different resonance structures, and we're going to need to figure out which one is most likely based on the formal charge, the assignment of the electrons. So I'm going to go ahead and just draw the 3. If you need, you can go back and review how you get to these situations, okay, how you get to look like this, but that's one of them, okay, which is a double bond on both, and we'll bracket it and put the minus because it's negatively charged. Okay, the next one would be if you had the triple bond between the sulfur and the carbon, the single bond to the nitrogen. Okay, again, we need to note this negative charge. This negative charge part becomes actually quite important in this, and the reasoning that that becomes so important, that you have the brackets with the negative charge, is because we're going to be writing in formal charges, sort of minus ones, plus ones. You need to make sure that that overall charge doesn't get lost in the shuffle. Okay, so sulfur to carbon, and we've got triple bond now to the nitrogen. Alright, so those are the 3 Lewis structures that you can draw for this molecule. Okay, and now what we're going to do is we're going to go through and analyze them for formal charge. So, important thing to remember is that the formal charge is equal to the number of valence for a molecule. It's the number of valence electrons that it has once you get off the table, minus the assigned. So in this case, for the sulfur, if we were to look really quickly, sulfur has 6 valence electrons on the table. Okay, and if we look at this first structure that we drew at the double bonds, that sulfur has 2, 4, and then we're going to count half of each bond belonging to the sulfur. Okay, so even though it has 2 to complete its octet, we're only going to count one of those as belonging to it. So it's got 2, 4 from those lone electrons, and then 5, 6. So it has 6 valence, assigned 6, so it's going to have a formal charge of 0, which we don't usually write in, so we don't need to worry about it. The carbon next to that has 4. Okay, and we're in the same situation here. It's got 4 assigned to it, 4 valence, 4 minus 4, 0. This nitrogen over here, 1, 2, 3, 4, 5, 6 assigned to it. It has 5 valence minus 6. It's going to be minus 1. So I'm going to write that in on the nitrogen. Okay, it's got a minus 1 formal charge on that nitrogen. Now, one of the things you'll note, 0, 0, minus 1, it adds up to whatever the charge is of the overall ion, which should make a lot of sense because really we're taking valence minus assigned, right? So if it's a minus charge, there's going to be one more assigned than there are valence from the sum total of them because we've added an electron. Okay, so let's look at the other two quickly, and then we're going to figure out which one's the best. So in this case, down here with the triple bond to the sulfur, okay, we've got sulfur. We said it has 6 valence. It's got 1, 2, 3, 4, 5 assigned to it. So it's actually going to show up as a +1 here. The carbon, 4 and 4, again 0. The nitrogen, 1, 2, 3, 4, 5, 6, 7 assigned. So 5 valence minus 7 assigned, minus 2. Okay, and on the other side, the sulfur will be minus 1, 2, 3, 4, 5, 6, 7. 6 minus 7 minus 1. The carbon will be 0 again, and the nitrogen, 1, 2, 3, 4, 5 will be 0. Okay, so the trick with formal charge, what you're looking for is the thing that has the sort of least overall formal charge to it, is more likely than something that has larger formal charges. So the one down here, okay, where we've got a -2 and a +1, that's probably our least likely, okay, because we have two other ones that have -1 as the only formal charges, the others are at 0. So that's minimized the formal charge in the other two. Now between these two, we have to decide which one is most important. Major difference is where we're going to put this formal charge of -1. Okay, this one has it on the sulfur, this one has it on the nitrogen, and what the trick is going to be here is it comes down to the ruling of the one that has the highest electronegativity, the most electronegative element, is more likely to take the negative formal charge. Okay, if you think about that, the more electronegative an element, the better it will hold electrons, and therefore the more likely it is to be assigned an extra electron. Okay, in that case it's nitrogen, so what we can say is this one is sort of far and away the most likely to do it. That doesn't mean that you may not have some resonance to the other one, but it means that probably this is the one you want to look at first and consider as the best structure.